method and so on. And at the end of the day, kitu ambacho tunajaribu kuachieve is just to know how to design a complete structure. Kama umepewa a 20-story building, can you design that building using your hand? Then can you take that building to the structural software ifanyie the analysis and design huko hivyo perform the checks. So kuna procedure. Kitu cha kwanza utadesign slab wenye tulidiscuss jana. After designing the slab, you will now transfer the loads from the slab ukuja design your beam. Then these loads will be transferred to the columns. We design the columns or the piers. Piers hizi zenye zinatumika kusupport mostly kama unafanya bridge design. Bridge mtafanya 5th year or 4th year hapo. Then ukisha design your columns, then all these loads will be taken to the foundation. Na hapa hivi ndio tulisema kwamba kuna hiyo Hooke's law. Is it not Hooke's law? Newton's law. Sorry, nimekumbuka. So kuna Newton's first law, second law na third law. So the third law ndio yenye nasema action and reaction are equal and opposite. So if this column is acting, is carrying or is supporting a load of, say for example, 1800 kilonewtons, then we must have something that will resist this load for our structure to withstand all the forces. So what are we going to design to withstand this load? Considering that now in column yetu, so you must design the foundation. And for the foundation, as I said, you have different types of foundations that we are supposed to design. Kuna pad footings, kuna pad hiyo yenye ni moja tu. Then kuna combined. Combined ni yenye, for example, if you have 2 or 3 columns supported by one footing, then that is what we call combined footing. Then apart from this, we can also have the mat foundation, ama pia inaitwa raft. So mat or raft foundation, hii ni ile yenye it's like a slab. So ina support all the columns. You just come up with a mat of slab, then it will support all the columns. You don't have to come up with the parts and counting. You just come up with one, then it will support all the columns, and that is it. Apart from this, we have, sorry. Kidogo tu. Mbona kwa yangu imejaa vumbi? Now, so kwa foundation kuna kudesign pad footing, kuna combined footing, kuna mat or raft. Then apart from this kuna hiyo strip footing. Pia ujue how to design strip footing. Na hapa kwa strip footing ndio waonyesha the easiest way, especially tukiwa kwa AutoCAD. You don't have to redesign each and every time. You just have to come up with one template. Utakuwa una import tu wakati unafanya detailing zako. So hiyo ni strip footing. Then apart from strip footing, kuna hizi piles. Kuna piles. Apart from piles, pia tunaweza come up with the caissons. Kuna caissons. So mwende mwangalia these two, piles and caissons, how to differentiate the two. Na ujue when to use piles and when to use caissons. So there are different actually caissons. Kuna ile textbook wenye kuna pages mingi. Wenda utamwangalia kwa hiyo textbook, then you'll get these piles and caissons. So apart from all this, now you can combine. We will discuss this one. But now remember, ujue at least could design each one of them. Ujue tu could design all this, because hautajua ni building gani utakutana nayo in future. Ukishajua ku design pad, make sure unajua ku design combined, mat foundation, strip foundation, piles. Unaweza jipata kwa project kubwa kubwa ambazo zinahitaji piles, ama unaweza jipata kwa bridge design. So for bridge design, actually you'll have to understand how to design the piles, caissons, the piers. Now apart from all this, kuna walls, hizo shear walls. Tuta discuss hizi sana in detail. So here in procedure to design structure, and then at the end of the day, you have to provide the details. So I'm going to assume this structure, this one, it's just a simple one. Naonesha how to design the slab from A to Z. And then at the end of the day, I'll give you like a period of 1 or 2 days in PT at your own level using this at 110. Ukishamaliza even then niko sure sisi wote tutakuwa sawa. Now, kitu cha kwanza ni kuperform the precising. Precising pia inaitwa initial proportioning. Let me just write here. Initial proportioning in procedure. So kwa initial proportioning hii ni kujaribu kutafuta ni kama kutafuta size, the thickness of the slab, because if of the slab utakuja kupata slab ni itakaa hivi. So the distance from the top here up to this bottom, so this is the height of the slab. So for this height of the slab ni lazima ujue how to determine it. It's very simple. Number one, tutatumia deflection. Let me erase this one. Okay. So number one, kuna hii ya deflection. Hii ni rahisi sana. Nitakuja kuonyesha how. Kuna hii ya deflection. Number two ni kutumia experience. Hii ya kutumia to experience. Now for the deflection, I will show you this one because sasa we are learners. Ni lazima ujue deflection. Hii experience ni watu kama ni watu kama sisi kwenye tuko field, watu wenye wamekaa field 2 or 3 years, 2 or more years, kitu kama hiyo. Utakuwa unajua tu because utakuwa umefanya structures mingi. So ukiangalia building kama hii yenye tunaona, you can just provide, for example, the thickness of the slab you can just use 150 and this one will work. 150 will work. Lakini for you guys ni lazima mjue 150 inapatikana aje. Usiambie tu 150 then wewe unaenda nayo. Ni vizuri ujue 150 ilipatikana hivi so that in future utakuwa kwa position yangu, pia utakuwa unaambia mtu how to get that 150 and it will be so good. So ndaonyesha deflection. Hii experience tutaachana nayo for today, but as you gain more experience on how to give the height of the slab, then utaenda sasa kwa experience, utakuwa unasema tu let's use this. Now, apart from initial sizing or initial proportioning, tunaenda kwa final proportioning. Kwa final proportioning hapa hivi tunatafuta loads. So hapa hivi kwa loads ni vizuri ujue the different types of loads that structure yako is going to be exposed to. So the first load is the dead load. Na hii dead load kuna different types of loads hapa kwa dead load. The first dead load is self weight of the structure. Now for the self weight of the structure, hii hapa hivi it's like, because hii ni material yenye tunakuja, the concrete material yenye tunakuja kutumia kuunda slab yetu. Sasa hiyo concrete material yenyewe ni lazima utafute load yake, na hiyo load ndio tunaiita self weight. Tutakuja kuona how to determine this self weight. Then apart from the self weight, kuna partition loads. Hizi partitions nitakuja pia naonyesha how to get them. For the self weight we calculate. For partitions we always assume a range of 1 to 2.5. 1 to 2.5. This one is kilonewtons per. Kwa code niko nakuja kuwaonyesha. So this how do we know the exact value yenye tunakuja kupeana. Partitions, for example, for this building utapata kama the architect amekupatia the structure, you will have to figure out how to do the structural layout. Mnaweza enda kwa YouTube video yangu mtaipata how to prepare the structural layout. Watch that, nimeunda video mzuri sana, unaweza ifuatilia. It's just a 1 hour video at your own time. Go and look at it, then mtasaidika sana. Let me show you something. Sijui kama niko nayo hapa. Marshall Kwale Residential. Hii ni structural. Let me check architectural. Now, kuna bima here hivi recently hii hapa. Now, kwa building kama hii ni wewe utaamua pahali penye unaweka columns, ni wewe ndio utaamua pahali penye unaweka beams. Then at the end of the day you will come up with something like this, because hapa tunaweza assume there is a column here, there is another column at this point, there is another column at this point. So what remains is the beams. So utapata this one, hii line yenye tumechora, these ones are our beams, hizi ni beams and so on. And now this beam and this beam iki anakuja kutupatia a slab here. So this one is a slab, these ones hizi ni slabs hizi. So considering that this one is our architectural plan, utakuja kuona ya kwamba for this part, let me just zoom hapa hivi, utakuja kuona for this WC, the water closet, kuna WC for ladies and WC for gents. Now this water closet iko na partition walls, kuna hizi walls hapa hivi, but now in the structural part we actually don't need to put all this as the beams. We don't have to put beams here. Tunaweza amua tu tukuje na one beam hapa, then another beam hapa, then all these internal walls hapa hivi hatutazieka. So for the structural layout utapata tuko tu na something like this. Tutakuwa na hii beam yenye nashuka this one, then hii yenye na separate this room, hii ya ladies na ya gents, but these walls hatutazi include. So these are what we call the partitions. We will just include them later as partition walls. Then kama ni for example the building for example the residential building, utakuja kupata inside the building tunaweza kuwa na the WC, kuna ile WC kwa master bedroom ndani. So hizo walls zenye tunatumia ku come up with the WC, ama some of the bed sitters utapata kuna WC ndani. So those walls zenye unaacha zenye uta design is what we call now the partitions, and the loads for partitions in a range of 1 to 2.5. Now where do we get this one? Nataka tuende haraka, please be noting these things down. Where do we get these partition loads? You'll go to BS 6399 part 1. That one will give you the loads. And how do we get that BS 6399? To your browser, for example, Chrome, just type BS 6399. Kama mimi hapa hii, this one installed just for part 1. Then you can always be using PDF copy, this one. Then ukuja download your BS 6399 part 1. Now, sita download because niko nayo. Ndakuja hapa hivi kwa my 69 part 1, this one. When we go to class 4 will tell us something, but I don't want to go there right now. Wacha tuende class 6.1 tuone nini iko hapo. Kuna hii, tutaanza na hii 5.4, this one. Hii kanatupatia how to get the partition loads. When you read through, itakupatia some important information. Itakuambia, for example, when permanent partitions are indicated, their weight should be included in the dead load. So first of all, remember partitions, point ya kwanza hapa hivi tunachukua kama dead load, and that's why ukikuja hapa hivi under dead load tuko na self weight, nimeweka partition loads. But now how do we get partition loads? To get the partition loads you can read all through, but now kuna pointi muhimu hapa hivi. Itakwambia kwamba for example for offices the minimum is 1 kilonewtons per meter squared. So this is the minimum, whether uko na partitions ama hauna, just be taking this value should not be less than 1 kilonewton per meter squared. Then so that's why umeona nimewambia it is given in a range of 1 to 2.5. But now where is this 2.5? So mostly be using 1.5. Mimi utumia 1.5 mostly for my design, almost all buildings, because hii ni value yenye una assume, si value yenye pengine engineer atakuquestion na aseme mbona hukutumia tu. Utakuwa na reason yako useme in a range of 1 to 2.5 I just decided to use 1.5, and that is okay. Now how do we calculate the dead load? Dead load, you'll go to class 4 of BS 6399. Then this class will guide you on how to calculate the dead load. Class 4 hapa hivi. So to calculate the dead loads wanasema loads are calculated from the unit weights given in BS 648. Now, ukienda kwa this BS, I don't want to go there because of time, but I will show you how to calculate that. From the unit weights are calculated from the unit weights. Now, so this means, let me erase this. This means to calculate the self-weight, you will take the density of the concrete, that is the weight of concrete, then you'll multiply this by height of the slab. And remember, hii height of the slab tumeitafuta kwa initial proportioning, naenda kuonyesha how to get it. So through this, you'll calculate the self-weight or the unit weight of concrete, that is density of concrete multiplied by the thickness or the height of the what? Of the slab. Then partitions nimewambia tunapeana in a range of 1 to 2.5. Apart from these two, pia kuna services to our building. Now, services ni kitu kama gani? For example, tables, kuna chairs, kuna screens, TV, kuna hii screen support, hiyo table, hiyo how do you call it? Hii yenye na support TV. For example, some of us tunaweka kwa wall, tuna mount our TV kwa wall, but wengine wanaamua wanaweka tu kwa hiyo meza yake. Then kuna chairs, kuna so many things. Hizo vitu zote zenye ziko kwa nyumba zenye zinakusaidia ku run daily activities, or those are what we call services. So for services we always assume the loads, because hii ni kitu yenye hauwezi ukasema wacha nikae chini ni calculate. So for this one we always assume 1 kilonewton per meter squared. Then lastly kuna finishes. Now, finishes ni vitu kama gani? Number one, kuna vitu kama kuna ceiling board, kuna tiles, kuna paints, kuna curtains, kuna windows. Hizo vitu zote zenye huwa to include. Tukikuja kwa kitchen, for example, kuna hizi the kitchen cabins. So all these are what we call the finishes to our building. So how do we calculate the loads for the finishes? It's so difficult to calculate these loads. So what we always do, you assume. So for this one, we always assume 1 kilonewton per meter squared. And it also depends with the nature of the structure. Some of the buildings where you can end up assuming 1.2 kitu kama hiyo, but usipita 2 kilonewtons. So ukishapata services upate finishes. Partitions nimewambia in a range of 1 to 2.5, and we always use 1 or 1.5. Then tushamaliza, you'll just go to refer to BS 648. EBS itakupatia density of the materials. Kama unataka density of the iron sheets, density of concrete, density of wood, density of anything, any material that is used for construction purposes, you'll get it from this BS. Na hii tumeipata wapi? BS 6399 part 1 clause 4. This clause, it will tell you that dead loads are calculated from the unit weights. Yes, 648. So ukishapata hivi, then hapa tumemalizana na final proportioning. Tushapata dead loads, so tunakuja pia tunatafuta nini? Live load. So how do we get live load? So tuko na live load. Live loads sitaandika in full, hivi tu inaeleweka. So for the live loads, where do we get the live loads, or how do we calculate it? So live load had to calculate. This one you'll go to BS. This one you'll go to BS 63 yenye tumefungwa 99 part 1, then table 1. So when you go to this BS, based on the nature of structure, how will you know the nature of structure? For example, hii building nimefungua saa hizi, kuna hii first floor plan. Ukiangalia tu hii building, kama hapa hivi kuna boardroom 1. Boardrooms, these are rooms used for meetings, for example, for presentations, vitu kama hizo. Kuna accounts office, kuna hapa hivi kuna financial office, kuna debut principals, academics. So you will realize this is a structure for office use, like ni maofisi ndio ziko hapa hivi sana sana. Then vitu zingine kuna hapa hivi kuna kitchen, but mostly this one is used for office use. Now when you come here, as I said, you'll go to BS 6399 part 1 table 1. Then yes, nilishaifungua. As I said, I don't have to send you this BS. Just come to your browser, search for it, and as I said, I always use this one, PDF copy. Hii inatumika, it's very simple. Hizi zingine zitakuitia like wanataka ulipia and so on, but this one is free. So you can just download your PDF from there. Now, BS 6399 part 1. Then as I said, table 1. This table will give you the live loads based on the nature of the structure or the use of the structure. So you'll just scroll down, then you'll come here to table 1. So what are you going to get from this one? This one will give you the minimum embossed floor loads. Now we have 4 columns. We have this column, this one, and this one. So the first column will give you the type of structure or the use of the structure, how that structure is being used, is going to be used. So if it's a structure for domestic and residential activities, then your structure will be categorized or will be put in category A. Then category B, this one is for structure for office works, office and work areas not covered elsewhere. Just to know, category B, this one is for offices. Then we have category C. Category C hizi ni kama makanisa, the cinema halls and so on. So kuna category C ya kwanza, hii the areas where people may congregate. Example, kuna public, institutional or communal dining rooms and lounges, cafes, restaurants, cinema, hotel and so on. Then kuna C1, areas with tables. For example, kuna kama una design for example inaitwaje library, then you'll come here to category, for example C1, reading rooms with no book storage. So this one hii hapa hivi library haiko hapo kwa sababu library watu tuna store books, so you cannot pick this one. Then kama una design classrooms, then you can use, so hapa hivi this one will give you the type or the category of the use of the structure. Then the second column will give you the examples of the use, ndio uelewe vizuri. Then the third column will give you the loads, the uniformly distributed loads, the pressure loads. So I will advise you to be using this one. Then the last one will give you the point loads. So these point loads, don't use them because kwa slab we always don't use point loads, natumianga area. Come on, design classrooms, then you'll just come here and pick 3. So this 3 kilonewtons is the one that you'll select. Then category D will give you the areas for the shopping areas. Come on, design maduka, the commercial building for commercial purposes. Then you can just come here and select your load. As you can see, this one is 4 kilonewtons per meter squared. Then come on, nafanya warehouse. I saw someone doing the for example, pale nyuma nimefanya a warehouse. I don't know kama ninaweza ipata haraka. Structures, projects, kuna warehouse. Hii ni ya Rwanda. Kuna hii kazi ya Rwanda. It was a simple warehouse. It's just a simple one. So kama unafanya something like this, then this one is the warehouse. This one is the architectural plan, as you can see. So something like this, you just come here to category. You come here to category. Let me close. You come to category E. Then you search for the example of the use of the specific use of the structure. Then from there you can now select the loads from this third column. Ukisha select now, for our case, assuming that this is the building for general use. For general use, you'll go to category B. Category A ni domestic. So kuna hii category B, this one is for offices for general use. You'll just come here, then unatafuta examples. So mimi ndakuja hapa hivi for offices for general use, utapata load yake ni 2.5. So this 2.5 is what I will select. You just select that one, office, for example. Sorry, Control Z. Okay. I'll pan this one juu kidogo hapo. Now for the office, load yake tumepata ni 2.5 kilonewtons per meter squared, and this is what we are going to use. Ukishapata load zote, now you have to perform what we call load combination. Remember kwa slab tunakuanga tuna loads mbili, dead load na live load. But when you come to medium and high rise building, now you have to factor in some other loads like wind load, earthquake loads, kuna snow loads, but in Africa snow haiko, even in the whole world snow imeanza kupotea. Mostly ilikuwa inasumbua Canada, but nowadays ni kama inaenda ikipotea because of the global warming. But wind we have tukianza kufanya some serious projects, some complex buildings, we will have to factor in wind loads and the seismic loads, the earthquakes. But for this small structure, we'll just consider dead loads na live loads. But now, for dead loads, as we said, kuna self weight. How do you calculate self weight? Unachukua density of the structure multiply by height of the slab. But the height, lazima tufanye precising. So if precising, then waonesha how to do that, because hatuwezi tukaendelea unless tumepata height of the slab. Now, to calculate the height of the slab, this one will go to BS 8110 part 1, then tutaanza na table 3.9. Actually, this is the first table yenye ndakana uende uangalie. So table 3.9, it will give you the, let me delete this. Table 3.9 will give you the ratio of span to depth. So span to depth, acha tuende huko. BS 110, I want table 3.9, nika hapo. This one is going to give you the basic span to effective depth ratio for a rectangular or flanged beams. We will discuss what is a flanged beam, but now for a rectangular, this one is the slab. So we have different types of slabs. Kuna cantilever, kuna simple supported na continuous. So ni vizuri uelewe what are these. Cantilever slab ni ile slab, I'll just draw it here, somewhere here. Now, assuming that we have one column here, assuming that this one is our column, then we have another column here. Then this column, we join these two columns using a beam. Tunakuja tunaweka beam yetu hapa. Then, kutoka kwa hii column, tunakuja tunaweka, this one is now the slab. This slab is only supported on this one side, is only supported at this point. Then this one is what we call cantilever slab. It is supported on one side, but the other side is not supported. So this one is what we call cantilever slab or cantilever element, because it can also be a beam. Then apart from cantilever, we also have the simple supported slab or simple supported beam. What is that? If we assume that this one is our slab, then tunakuja tunaweka hapa column, tunakuja tunaweka hapa column, tunakuja tunaweka hapa column like that. It can be the circular or rectangular column. So assuming that these are our beams, then in the ile sasa simple supported slab. Hapa juu tunaweka water tank, kitu kama hiyo. I think mmeona vitu kama hizi. We just come up with the 4 columns at the corners like this. Then hizi ni beam zetu zinashikilia slab. Then kwa hii slab tunaweka water tank. So hii slab yenye ni slab moja peke yake. Hii slab yenye iko tu peke yake. We don't have any other slab side, this end or this end. This slab is what we call the simple supported slab. Now for the continuous slab, ni kama hii ya building yetu yenye tumechora hii. Utakuja kupata hii ni slab, this one is the slab. Like this slab is connected to another slab, which is connected to another slab, hivyo. So the continuity, there is some continuity to our slab. So this is what we call continuous slab. So for our case, we have a continuous slab. This one is our continuous slab. So we have to get the ratio. So for the continuous slab, and we are dealing with, remember, slabs in a rectangular section. What is a flanged section? Flanged section is in the beams. Hizo tutascuss baadaye tukifika kwa beam. I'll explain more about this. But for the slab, we always use rectangular section, because hivyo ndio venye iko. Venye tumechora hii, this one is just a rectangular section, hii pia ni rectangular section, hizi pia hapa juu, these ones are rectangular sections. So section. Now what is the we are taking the basic span divided by effective depth, then we must equate it to the value that we are going to get from table 3.9. So considering the container and its rectangular section, then the value is 6. You just put here. Now, to get D or interest to get what? H, because this is this so you have to get this. But if you na tuangalie itakaa hivi. So this is from top to bottom, as I say. Now the sorry, let me put this one to power. Remember we are used to about 2.8. So this basics kuipata, but jaribu kufigure out peke yako baadaye, tunaona ni rahisi kuipata because tunayo by the way. Our is to get D. So for the subject formula. So D for this formula, you make subject of the when multiply D na 26 tutapata 26D. So hapa tutapata S is equals to 26D. So you get D hivi na 26 na 26. So utapata our D is equals to 26. But now to modify this formula, I'll tell you later how to say it. But now to modify this formula, you have to multiply it by the print itaonyesha penye natoka later, but this is the formula. Now, what is D? What is D? Tukikuja kwa hii diagram yetu, tunajua hii slab yetu inafaa tuweke reinforcements. So assuming that tuko na bottom reinforcement hapa hivi, these are the bottom reinforcements, bars zinaenda kwenda na ndani hivyo. So I'll cut this section from here kupita katikati ya reinforcement zetu. So nataka tu assume imepita katikati like that. So the distance from the top to the center of bottom reinforcement is what we call D. This D. That is now the D. The distance kutoka hapa juu up to the center of the bottom reinforcement. Then na zoom nataka tuone. Then okay, acha ni erase kitu hapa, nataka ni key point tuielewe vizuri. Good. So kutoka hapa juu hadi hapa, this is what we call D. Now this is called effective depth. Ukiangalia kwa hii formula wamesema effective depth. That is now the D. Then H is what we call total depth. Na hii ndio client anataka kwa sababu hii ndio watajenga. But hii kinaenda kutusaidia kufanya the design. Now, how do we get H? D tutaassume tushaipata. Kwa hii formula yetu hapa, D is equals to S over 26. Na S tuko nayo. S hii ni span. Tena naweka hapa span. Hii span niko nakuja kuonyesha, tunakuja kupata hii span hapa. But now nataka naonyeshe how to get H, because after getting D ni kutafuta H. So how do we get H? Kupata h ni lazima tupate the distance from now the bottom of the bar up to the bottom of the slab. So what is this distance? Hii distance yenye nimeichora hapa hivi. So this one is what we call the cover to our reinforcements. Now, then apart from this cover, tuko na hii distance hapa, hii distance imebaki because ukiangalia kutoka kwa a half the bar to the cover now, tuko na hii distance. So what is this distance? This one. Hii utachukua diameter of the bar divided by 2 because hii ni diameter full but now a half yake ndio iko chini. So you'll just take a half the bar then divide by 2 like that. Someone okay. Now tuko na cover. How do you get this cover? Hii cover utaenda kwa BS ETA 110 part 1 then uende table 3.3 and table 3.4. So these two tables will give you the cover. But now for your information, the cover to be 25 millimeters. So ukiangalia hizo vitu zenye niko na explain, they'll actually take much time, but it's very easy for us to understand. So if the cover is 25, then what is the diameter of the reinforcement for slab mostly? Tunatumianga diameter 10. So this one you'll just use diameter 10. So to get this one, you'll just take 10 because we want a half the bar divided by 2. So a half divided by 2, this one is 5. Tuko nayo hapa hivi. Now, sasa sikiza hapa because hii ndio point mzuri sana. How do you get this span? Because tumesema D is equals to S divided by 26 times 1.3. And our S now, how do we get this span, effective span? Or the basic span? So, please confirm this one. I'll open the Excel, ndio itumike kuwasaidia kuelewa kidogo. As I said, the first thing from BS 648 ni lazima ujue density of concrete yenye unaenda. Na mjue density of concrete mostly tunatumianga 24 ama 25. So for this one I will just use 24 as default. Then tuenda directly kwa slab design. So hapa kwa slab design discuss baadaye because we need it. Kwa initial proportioning, as I was saying, kwa hii diagram yetu hapa hivi, kwa initial proportioning hapa kwa initial proportioning kuna two ways. Kuna hii ya deflection then kuna hii ya experience, but sasa sisi tuko tunafanya deflection. Hii ya deflection kuifanya tunahitaji kutafuta D, ndio tutapata H from D. So kutafuta D we need the span, then we will take span divided by 26, then we will multiply that by a modification factor of 1.3. So when you come to this Excel, it will also ask you the same question. Here you'll have to enter the span, then you calculate, then you have to enter the span. But what is this span? I want us to read this, that this refers to the deflection span. Ama pia inaitwa basic span. As you can see here, it is called basic span. That is, this is the longest short span from all the short span in the whole structure. Hii statement nataka muielewe venye iko hivyo, acha tuende huko ndio mtaielewa. The longest short span from all the short spans in the whole structure. So what is that? Utakuja kwa hii structure yako hii yenye utakuwa umeunda kwa AutoCAD for example. Acha ni erase hii. Then kwa hii structure yako utatafuta the short spans. Utatafuta the short spans. So please follow me because ni ngumu. Ukishaelewa hii niko sure utakuwa umeelewa hata Excel yote. Hapa ndio usumbue kidogo. So utaenda kwa kila panel. So these ones are called panels. Utaenda kwa kila panel ama kwa kila slab utafute the short span. So kwa hii panel ya kwanza This one is 3 meters because hapa hii ni 3. Acha niandike hapa pia. This one is 3. This one is 4.5. This one is 5.0. This one. So, kwa hii panel ya kwanza tuko tuna compare 3 na 4. Tunachukua the shorter of the two, or the smaller value comparing the two. So 3 na 2 utapata the shorter span or the shorter side ni 3. Then kwa hii panel ya pili we are comparing 4.5 and this one is 4 meters. Hii 4 meters. So comparing 4 by and 4.5 utapata the shorter is 4 meters. Then excuse me. Okay. For this panel, we are comparing 5.0 and 4 meters. So the shorter one is 4 meters. Tukikuja kwa hii panel, we are comparing 3 and 3.7. So the smaller is 3. Then haraka kidogo, I think sasa tumeelewana. For this one, we are comparing 4.5 and 3.7. Ile ndogo ni 4.7. Then hapa we are comparing 3.7 by 5. The smaller itakuwa 3.7. Then hapa we are comparing 3 na 5.2. So tutatumia 3. Then hapa tuna compare 4.5 na 5.2. So 4.5 itawin. Itakuwa the shorter. Then hapa we are comparing 5.2 and 5. So tutatumia 5.2 ndio smaller. But now hapa hivi tumejaribu ku highlight the shorter spans or the shorter sides of each panel. Hapa hivi the shorter side ni 3, 4 hivyo. Now after we highlight all the shorter sides of each panel, now unatafuta the biggest value of all these red values. So tumeweka the red values as the shorter sides of each panel. Now which one is the biggest? For this one we have 3, we have 4.5 ni kubwa, then kuna 5. So hii 5, this is now our basic span. Hii yenye unaona kwa table 3.9. Hii basic span is now this value. Hii yenye tunaona 5.0. First of all, you highlight the short spans. Then after that, from all these short spans, you select the biggest. Hiyo statement yenye mnaona hapa hivi. That is the longest short span. Among all short spans, which one is the longest? Hiyo ndio tumefanya hapa. Ni nani hajaelewa? Because kama hujaelewa hiyo, fanya hiyo. Innocent, tuko pamoja. Tesha, umeelewa hiyo part? Innocent? Okay.
Kujiunga. Mtu anataka kujiunga.
Tuko pamoja.
Okay. Unaweza mute. Yes?
Akawa hajapata.
Unasema? Innocent.
Naam. Kuna mtu alikuwa anataka kuingia kwenye meeting.
Waingie tu, kuingia wanaingia tu bila hata mimi kuwaingiza. Nimeweka ni automatic.
Sawa.
Wataingia tu, mwenye anataka kuingia ingia tu, ni automatic kabisa.
Sawa.
Yeah. So uta highlight the shorter sides of each panel and then you pick the biggest value of all this. So for our case it is 5. So E5 sasa ndio our value yenye tumekuwa tunasema. Okay. Mbona imehang? So hiyo span yetu sasa hapa hivi itakuwa 5000. So when we take our calculator, nataka tutumie calculator for to make this, sorry, calc. Now naenda kutumia scientific. We have span tumeipata ni 5000. Then that span I'll just close. To divide by 26, then multiply by a modification factor of 1.3. So 1.147 millimeters. So that is D. D for this case is 147 millimeters. So you'll just enter here 5000. Then you have to select where this panel is being obtained. Ukiangalia from this model, hii panel yetu iko mwisho. Haiko, kuna hizo panel zenye ziko ndani, then kuna hizo zenye ziko nje, ziko at the edge, nje kwa ukuta kwenyewe. So we will just select, we will just tell Excel that this panel is being selected from the edge of the building. So hapa hivi kuna hii continuous. Continuous inamaanisha ni continuous slab, then interior inamaanisha imechukuliwa ndani. Kama for example tungechukua hii 3.7 as the basic span or the deflection span, then tungeiambia continuous interior, continuous slab but interior. But for our case it is continuous but at the end of the slab or end of the building. So utakuja kwa hii drop down, then uchukue yenye nasema continuous end, this one. Angalia modification factor is 1.3, then basic ratio 26. This basic ratio tumeitoa tu kwa table, so hiyo iko hapo hivyo. Then cover, as I said, this one you'll go to table 3.3 and table 3.4 BSETA 110, but be using cover as 25. Then we'll have to assume bar, the diameter of the bar as 10 millimeters. Now from there, the D calculated is 148. Kwa calculator yetu tumepata 147.9. When we round it up or when we round this one off tutapata 148 ambayo ni hii. Then itatafuta H. Now hii H imeitafuta aje? I will just explain because ni vizuri muelewe mbona ina behave hivi. Okay. Now kupata hii H, as I said, kupata H utachukua D, which is for our case 149, then plus cover which is 25, then sasa plus hii yenye imebaki hapa hivi ambayo ni nusu ya diameter of our bar ambayo tumepata ni 5. So when we take 149 plus this one is 30, tutapata 179. Na hiyo 179 ndio hii hapa hivi imetupatia 178, which is just okay. Or this one was 148, not 149. 148, so utapata 178. So this 178 you have to round the value to the nearest 25 millimeters. You round it up to the nearest 25 millimeters. Excel ishakufanyia imetupatia 200 and the revised this one 170. But now the value yenye nitakana tutumia hapa ni 200. So hiyo ni height yetu. Tukishamalizana na initial proportioning tunakuja final proportioning. This final proportioning is very important. Kwa final proportioning, as I said, hapa tunatafuta loads. Na kwa loads nimesema tuko na loads aina mbili, kuna dead load na live load. Kwa slab kuna dead load na live load. Self weight tunachukua density multiply by height of the slab. Na tulishasema ya kwamba density of the slab ni 24, so you'll just take 24, then utai multiply na height of the slab which is 200 millimeters venye tumeona this one. So this 200 unaiweka kwa meter because we are working in metric units, so 200 itakuwa 0.2, that one. When you multiply utapata 4.8. So tukikuja hapa this 4.8 ndio hii imeshaji calculate 4.8. Now this partition loads, as I said, we'll get it from clause 5.14 of BS 6399. This BS, when you come to clause 5.14, this one will give you the minimum value. The minimum value is 1 kilonewton per meter squared. But the maximum value niliwaambia it is 2 kilonewtons per meter squared. Ni wewe in that range, wewe ndio unaamua unataka kutumia value gani, sorry. But as I said, for partitions, I always use 1.5 kilonewtons. But you can also use 1, you can also use 1.75, you can also use such. So for this one, I'll just use 1 kilonewton, the minimum value. Then kuna services and finishes. So services and finishes combined. But remember, services niliwaambia tutatumia 1, then finishes tutatumia 1. So tukicombine hizi mbili tutapata services and finishes ni 2 kilonewton per meter squared. After that, you have to add these loads. You have to put them together. So 4.8 plus 1 plus 2, you'll get 7.3. After that, kuna This live load, as I said, you have to get it from BS 6399 part 1 table 1. Na hii tushaenda huko, tushaona how to get that. Tulitumia offices for general use hapa, offices for general use, this one, as you can notice, 2.5 kilonewtons per meter. So this 2.5 will just enter it here. Unafanya load combination. How do we do load combination? How do we get this N, the total load now? To do this, you'll go to BS 110, table 3.5. Pale ndani itakuambia, this one is BS 110. I'll go to table 3.5. So, hapa, I think nimefika this one. So, to combine the loads, the dead load and live load, you'll use this formula. Kindly take note of this. Sijaweka kwa Excel. But make sure you take note of this formula. So, F, which is now N for our case, this is the total design ultimate load, which is given by 1.4 dead load, GK is dead load, then plus 1.6 QK, which is now the live load. So when you come to this Excel, dead load is given by 1.4, live load is given by 1.6, as we can see from this. Tuko na hiyo 1.4 na 1.6, hizo ndo nimeziweka hapa hivi. So hizi zitatumika kama multiplication factors. So when you do that, ukicombine hivyo utapata 14.92. Now, ukitaka kuona hizi load venye tumezifanya in a systematic way, unaweza kuja kwa Excel hapa useme show step by step calculations hapa hivi. Then hapa juu kuna hii final proportioning hapa. Initial proportioning tushasema. Kwa final proportioning tutaanza na permanent loads GK. Kuna self weight. Self weight tumechukua height of the structure, height of the slab which is 0.2. Hiyo ni hiyo 200 yenye tumecalculate huko, multiply by 24 umepata 4.8. Then extra dead loads, that is partitions, surfaces and finishes, tumechukua 1 plus 2 tukapata 3. Then total dead load denoted by GK is 7.8. Then for the embossed or live loads, it may be 6399 part 1 table 1, tumechukua 2.5. Then total ultimate design load and tumepata 14.2. Hiyo ni procedure. Kufikia hapo nani hajaelewa? Because now tumeshamaliza part mbili. Part ya kwanza ni kutafuta the height. Kutafuta height, the initial proportioning. Shapata height yetu ni 200, nishawaonyesha how to get this. But now remember, pia code imetuambia the minimum thickness labo yenye usitumie a minimum value that is from class 7. So let's go to class 7.
kujiunga. Unanisikia?
But unaona hapa
Ingawaje
hivi
mimi kwa
nimeweka
upande wangu nilikuwa nijaribu kujiunga tena mara ya pili, nikaona imekubali. Sasa sijajua kwa nini wengine kwao imekuwa ngumu.
umeona okay, I think in the next meetings Innocent utakuwa na create nini link so that kuna monitor kuingia kwa watu sawa sawa.
Sawa.
At least hiyo unaweza saidia because unaona sasa kama niko nafunza itakuwa ngumu sana niangalie nani ndakana ajiunge nani hajajiunga, si unaona? So next time create link alafu you can share. Any other concern nataka tufungie hapo, naona ni kama leo nimekuwa imechoka.
Eric, kuna swali? Innocent, kuna swali?
No question, no question.
Sawa sawa, wacha tufungie hapo hivyo. Innocent, I think you just pass the message to the rest of the members. Whoever sees this online session to be important because hizi vitu zenye nawafunza sijui Tanzania but Kenya sisi hakuna mtu atakufunza hizi vitu klasi. Hizi nitakana pengine uende YouTube ikupeleke huku na huku ikuzungusha ndio pengine usome, lakini class mtabaki tu kwa hiyo moment distribution na vitu zingine kidogo, but class ni ngumu kujifunza vitu ambazo nawafunza saa hizi. So
sisi kwa upande wetu
yes,
kipindi hiki hapa ni kipindi cha likizo ambacho tumebakisha tu kama wiki hii moja.
okay,
afu ndo tufungue muhula wa pili. Sasa muhula wa kwanza ambao ni wiki kama 2 zilizopita hivi ndio tulikuwa tumetoka kumaliza mitihani ya mwisho, ambao kwa muhula huo tulisoma, yani kwa semester hiyo tulisoma design of steel according to BS 5950 na design of timber structures according to BS 5268 kama sio 5628. Sasa ila hiyo RCC ambao ndo discussionia sasa kwenye hii meeting tunasoma nani muhula huu hapa unaoenda kuanza.
okay,
Utasoma hiyo pamoja na masonry design muhula huu hapa. Kwa hiyo ndo maana tukaona kama tujiandae hata kwa mbinu mbalimbali ambazo zitatusaidia kusolve assignment zetu kwa urahisi zaidi.
Sawa sawa. Wacha later, wacha tufungia hapo, but nitakuwa na session na wewe, pengine kesho nitakupigia simu tuongee kidogo. Alafu but mtu mwenye